Hello friend, this is second part of Kafka and Spring Boot tutorial. In this video, we will learn about what is Kafka and we will see all the components of Kafka. Like we will see what is broker, what is topic, what is partition, what is Zookeeper, and what is producer and consumer. So let's go ahead. So first thing is what is Apache Kafka? So Apache Kafka is originally developed by LinkedIn, but now it's managed and distributed under Apache Foundation license. So Apache Kafka is a distributed streaming open source system for publishing and subscribing to a large number of messages from one end to the other. Here one end is the producer and the other end is the consumer. Here in this definition, we can see we have used two words, distributed streaming. So let's understand what is streaming. Streaming is a continuous flow of data. What is data? Data is content. Data is message. And distributed means multiple machines connected each other to perform a particular task. So Kafka is a cluster of connected machine for publishing and subscribing to a large number of messages from one end to the other. Kafka is best alternative of Amazon Kinesis, RateMQ and ActiveMQ. Now here we need to understand two important things in the whole architecture. First is producer and second one is consumer. So producer is someone who sends or publishes data to the Kafka topic within the Kafka cluster. We will see what is Kafka cluster and what is Kafka topic. And another one is consumer. Consumer is someone who reads or consumes the Kafka cluster messages by subscribing to the Kafka topic. So here producer and consumer can be anything. It can be an application, it can be a log file, etc. So in our implementation example, we will create a producer by Spring Boot application and our consumer application will also be of Spring Boot application. Now let's understand what is Kafka cluster. Kafka cluster is made of one or more broker. We will see about brokers in few seconds. It can be expanded and used without downtime. So Kafka cluster we can easily expand and we can easily reduce without any downtime. That's why Kafka is very well known for the fault tolerance. Kafka clusters are used to manage the persistence and replication of messages of data. So if primary cluster goes down, other Kafka clusters can be used to deliver the same service without any delay. Now let's see what is broker. Kafka server is called brokers, which is in charge of the topic message storage. Each Kafka cluster contains more than one broker for load balancing. So here in this example, we can see one Kafka cluster is having three broker. So broker is nothing but a Kafka server and Kafka server is nothing but a machine where Kafka is installed. So Kafka broker is responsible to store the topic message. Now let's understand what is topic. Topic is a very important part of Kafka ecosystem. A Kafka topic is a collection of messages that belongs to a given category. The closest analogy for a Kafka topic is a table in a database or a folder in the system. So in database, as we see that there is a table and inside the table there are columns and rows. So table is nothing but just a name, right? And it contains other data inside it. So here also topic is just a name for a particular category and inside the topic or to the topic we send the messages. So messages are associated to the topic. Topics are the central concept in Kafka that decouples producers and consumers. Producer always sends messages to the topic and consumer pulls off those messages from the topic. A topic can have many producers and many consumers. Another important part is partition. Kafka topics are divided into several partitions. While the topic is a logical concept in Kafka, a partition is the smallest storage unit that holds a subset of records owned by a topic. Each partition is a single log file where records are written to it in an append-only fashion. So in this image, you can see here, this is the topic, and this blue square and red square is the partitions. Whenever we write any data to the partition, that means it is always added one after another. Kafka keeps more than one copy of the same partition across multiple brokers. This redundant copy is called a replica. If a broker fails, Kafka can still serve consumers with the replicas of partitions that failed broker owned. Each partition Each partition has one server which acts as a leader and zero or more server which acts as the followers. The leader handles all read and write requests for the partitions while the followers passively replicate the leader. So in this diagram we can see there are three partitions for topic 1, and all of these three partitions is replicated to broker 2 and broker 3 also, and every broker will have leader and others will be replicas. So if in any case broker 1 is down, then the read and write operation will start happening from the broker 2 automatically. Now let's understand the partition offset. Each records in the partitions are assigned a sequential identifier called the offset, which is unique for each record within the partition. So in this diagram we can see there is a Kafka topic, and for this topic there is three partitions. So this is how the partition holds the actual data, and this particular portion is called offset. The offset is an incremental and immutable number maintained by Kafka. When a record is written to a partition, it is appended to the end of the log, assigning the next sequential offset. Offsets are particularly useful for consumers when reading records from a partition. So whenever a new data is being written to the offset, it will always return to the end of the logs and it will be assigned a next sequential number. Zookeeper. It acts like a master management node where it is in charge of managing and maintaining the brokers, topics, and partitions of the Kafka cluster. It keeps track of the broker of the Kafka clusters. It determines which brokers have crashed and which broker have just been added to the Kafka cluster as well as their lifetime. So Zookeeper is the one who keeps track all the configuration of broker, topic and partition. It knows that which broker is currently active and how many brokers are there, which one is crashed. All the information is with Zookeeper. Producer gets all this information from Zookeeper to write the messages to the topic. And consumer, while consuming the messages, it gets the updated offset value, and after consuming the message it updates the value as well. So now we have understood the Apache Kafka ecosystem. We have seen what is Kafka cluster, broker, topic, partition, offset under partition, and Zookeeper. Now let's see the benefit of using Kafka. Reliability. Kafka is distributed, partitioned, replicated, and fault tolerance. As we've seen already, Kafka is distributed because Kafka cluster is a combination of multiple brokers, which is nothing but a Kafka server. Many brokers are partitioned in multiple clusters and many topics are replicated to many brokers. That's why Kafka is very much reliable. Scalability. Kafka messaging system scales easily without downtime. Durability. Kafka uses distributed commit log, which means messages persist on disk as fast as possible, hence it is durable. We can store the topic messages for a longer time, even we can store it for the infinite time as well. Kafka has high throughput for both publishing and subscribing messages. It maintains a stable performance even though many terabytes of messages are stored. Here are some use cases of Kafka. First one is metrics. Kafka is often used for operational monitoring data. This involves aggregating statistics from distributed applications to produce centralized feeds of operational data. Log aggregation solution. Kafka can be used across an organization to collect logs from multiple services and make them available in a standard format to multiple consumers. Stream processing. Popular frameworks such as Storm and Spark streaming read data from a topic, process it, and write process data to a new topic where it becomes available for users and applications. Kafka's strong durability is also very useful in the context of stream processing. Kafka is not limited to only these use cases. There are a lot more use cases of Kafka. Okay guys, in next video we will download Kafka and we will run on the local machine.